Welcome to another video in our series. This is on polynomial identities. So before we start proving identities, let's just review polynomials. They are expressions consisting of addition or subtraction of variables and coefficients all raised to non-negative integer powers. Okay, so a couple things to take out of there. We're either adding or subtracting, that creates a polynomial, and we're adding and subtracting the variables. The powers, though, are non-negative, so they need to be positive, and they need to be integers. They need to be whole numbers. So if you take a look at these two examples, A and B, one of them is a polynomial and one of them is not. In example A, notice I'm adding or subtracting these terms, and all of my exponents are positive, non-negative integers. So I would say this one is a polynomial. In example B, I have a negative exponent, which I cannot have, and I have an exponent that's not an integer. So this one is not considered a polynomial. So now we'll get into the identities, and we talked about them a little earlier in the year, but we'll officially cover it today. An identity is an equation that is true for all values. Okay, an identity is an equation that is true for all values. So equation, of course, just means that we have to have an equal sign, and we need this to be a true statement for all values. So let me give you an example. X squared equals 2 minus x. This is an equation, but it is not an identity. Let me explain why. A, obviously the equal sign makes it the equation. Okay, now it's true for some numbers, but not for all numbers. For example, if I use a 1, 1 squared is equal to 2 minus 1. Well, 1 equals 1, that's true. However, what if I use 5? 5 squared equals 2 minus 5. Does 25 equal negative 3? No. So it's an equation, but it's not an identity. It's not true for all values. So here's our first example. X squared minus y squared equals x plus y times x minus y. A, test the identity with x equals 10 and y equals 2. So simple enough, I'm just going to substitute in and of course use parentheses. So I'm going to say 10 squared minus 2 squared is equal to 10 plus 2 and 10 minus 2. Alright, so I know 10 squared is 100 minus 2 squared is 4. I get a 96 here. Let's test this side. 10 plus 2 is 8. Whoa, no it's not. 10 plus 2 is 12. 10 minus 2 is 8. And 12 times 8 equals 96. So again, I didn't prove it's an identity. I just tested it with these two numbers. For it to truly be an identity, it has to work with all numbers. Part B. Now it says prove the identity. So recall the identity is x squared minus y squared equals x minus y times x plus y. So when I'm asked to prove it, I'm just trying to show that the left-hand side equals the right-hand side. Now sometimes you can manipulate both of them, sometimes just one of them. So my gut says if I look at the right-hand side, I can multiply, FOIL, distribute, I can clean this side up. So that's what I'm going to do. I'm just going to clean up the right-hand side. So I'm going to say that's x squared plus xy minus yx minus y squared. So that gets me x squared. Now, remember, we love the commutative property because we can change the order of these. So I'm going to say plus xy minus, I'm just going to change the order and call that xy minus y squared. That's just the commutative property. And then if I clean that up, I get, let's see, x squared, those cancel, minus y squared. And guess what? That's equal to x squared minus y squared on the left. So now you have proven it's an identity because the left side equals the right side. Part C says use this identity to evaluate 25 squared minus 24 squared. All right, well, how are we going to do that? Again, let me start with the identity on paper. X squared minus y squared equals x plus y times x minus y. So here's what I say to myself, guys. Basically, this looks like either the left-hand side or the right-hand side. I hope it's obvious. I have a number squared minus a number squared. I would say that looks like this side, a number squared minus a number squared. So I'm going to say, okay, that means x equals 25 and y equals 24. Notice it's not negative. The minus sign is already in the problem. I'm just saying my x value that I'm squaring is 25 and my y value that I'm squaring is 24. Now I'm just going to plug it into my problem. So that really means that's 25 squared minus 24 squared is equal to 25 plus 24 times 25 minus 24. Okay, and I just followed through with the x value, the y value, x value, y value. Okay, so now I'm going to keep cleaning up. I'm going to say 25 plus 24 gets me 49, and 25 minus 24 just gets me 1. So look how quickly we multiplied 25 squared minus 24 squared. That answer, it's pretty neat. To get 25 squared minus 24 squared, I just plugged it into this identity, and I did it without a calculator. I quickly got 49. Now, if you want to grab your calculator, if you don't know these off the top of your head here, 25 squared is 625, minus 24 squared is 576, and guess what? That gives you 49. So it's really a neat way that you can square numbers and subtract them by just using an identity, something that's always true. D. Use the identity to simplify and then evaluate 26 times 24. So again, they're going to want you to do this without a calculator. So I'm going to start with the identity. X squared minus y squared equals x plus y times x minus y. Alright, so I just have to figure out which side of the equation makes the most sense to use. Do I start with this side or this side? Well, I said basically I don't have anything squared like I did in the previous problem, so I think I'm going to use this side first. I need this to say 26 and 24, where I take a number plus a value and the same number minus a value. Can you guess what you would want x to be? Think about this. When if I said x is 25 plus a number and then 25 minus the same number, could you get me 26 and 24? I think so. I could say 26 plus 1, or I'm sorry, 25 plus 1 is 26, and 25 minus 1 is 24. So you see how I'm using this side and kind of going backwards? Alright, so that must mean my x value is 25 squared minus my y value is 1 squared. And we just said 25 squared is 625 minus 1 squared, so I know that this must be 624. And again, I can grab my calculator and verify that 26 times 24 is 624. Okay, so maybe if that one went a little too fast, let me go back and just talk it through again. If I want to quickly multiply 26 times 24 without a calculator, I basically said it's a number plus a number and that same number minus the same number. So I said, okay, the difference is 2, 24 to 26, so I knew 25 was in the middle. 25 plus 1 got me 26. 25 minus 1 got me 24. Then I said, okay, I'm just going to work backwards in the identity. So if x is 25, I plugged it in here and got 25 squared. If y is 1, I plugged it in here and got 1 squared, which is 1. And 625 minus 1 is 624. All right, next example. Verify the polynomial identity. So again, basically they're saying, make sure this side is equal to this side. Again, sometimes you're going to manipulate both sides, sometimes just one. Just go where you feel it. I'm going to start on this side because I know how to square something. And again, that means write it down twice and multiply. So x plus a squared is really x plus a times x plus a. And notice I'm going to kind of put that in a bracket because then it says minus this quantity. And I'm going to bracket this one in. X minus a squared is x minus a times x minus a. And hopefully I get a 4ax at the end. Now you'll see why those brackets are so important in a moment. But I'm going to go ahead and, like I said, multiply this out. So that's x squared plus ax plus ax plus a squared. So x squared plus, hopefully you're getting 2ax plus a squared, minus, I'm going to multiply this out. So that's x squared minus ax minus ax. So that's x squared minus 2ax. Now I'm going to get a plus a squared because I have a negative times a negative. And again, hopefully I get a 4ax. So these identities are kind of nice because they basically give you the answer. You just got to prove it. Now, why were these brackets so important? Well, don't forget, when you subtract, you have to take this negative and distribute. So I'm basically going to turn this to a plus, and I'm going to make this a negative x squared, a positive 2ax, and a negative a squared. And then I'm going to put all these together. So I'm going to say x squared and negative x squared cancel. 2ax and 2ax make 4ax. And positive a squared and negative a squared cancel. So you'll notice I get 4ax equals 4ax, and we've just proven the identity. The polynomial identity, the quantity x squared plus y squared squared equals x squared minus y squared squared plus 2xy squared, can be used to identify Pythagorean triples. So let me just remind you about Pythagorean. That's a squared plus b squared equals c squared. Okay, and triples are numbers that work in there. So if you recall from geometry, maybe even algebra, this is your a side, your b side, your c side is always the hypotenuse across from the right angle. Anybody that works in there is going to be called a Pythagorean triple. So this says, generate a Pythagorean triple using x equals 4, and I apologize, this should say y equals 3. So let's go ahead and fix that. X equals 4 and y equals 3. Okay, so I'm going to carefully substitute these numbers in. So I'm just going back to this equation, and I'm replacing my x with 4 and my y with 3. Lots of parentheses. So I'm going to say that's 4 squared plus the quantity 3 squared, all squared, equals 4 squared minus 3 squared, all squared, plus 2 times 4 times 3, all of that squared. Okay, now we'll just go through and we'll do the math here. So this is going to get me 16 plus 9 squared, which would get me 25 squared, which is going to be equal to, this is going to be 16 minus 9 squared, which will get me 7 squared, plus 2 times 4 is 8 times 3 is 24 squared. Now I want you to stop there. Okay, I don't actually want you to go any further. I want you to think about this. Do you kind of see the setup going? A squared plus b squared equals c squared. So if this is true, if this number is equal to these numbers, then we have a Pythagorean triple. So let's verify. 25 squared is 625. 7 squared is 49. Plus 24 squared is 576. So I do, look, I get 625 equals 625. So now we've proved that we have a Pythagorean triple, but what are the numbers in the triple? Well, I'm going to go back here, and I'm going to say this was a squared plus b squared equals c squared. So the numbers that work in the Pythagorean triple are actually a equals 7, b equals 24, and c equals 5. So let's write down our triple. 7, 24, 25. Those numbers will always be guaranteed to be true in the Pythagorean theorem. So show that these sides will be the side length of a right triangle as long as x is greater than 1. Now why am I saying x is greater than 1? Well, if I plugged 1 on this side, I would get 1 squared, which is 1 minus 1 is 0, and having a side length of 0 doesn't make any sense. So they're just telling me my number has to be bigger than 1. No need to fret. So basically, because this is a right triangle, I'm simply going to apply the Pythagorean theorem. A squared plus b squared equals c squared. And remember, a, b is my base, c is the important guy. It has to be the hypotenuse. I'm just going to carefully plug them in. The quantity 2x squared plus the quantity x squared minus 1 squared has to equal the quantity x squared plus 1 squared, according to the Pythagorean theorem. Now I'll just do the math. Remember, squared means you have to write it down twice. So this means 2x times 2x. So I know I get 4x squared. plus x squared minus 1 squared, means write it down twice and multiply. So that's going to get me x to the fourth minus x squared plus 1. And then that last term, again, I'm just going to write down twice and multiply. X squared plus 1 times x squared plus 1. So equals x to the fourth plus x squared plus 1. So remember, if it's an identity, I should get the same thing on both sides. Well, if I subtract x to the fourth, those disappear. If I subtract an x squared, I'm going to add an x squared, and I'm going to add an x squared. I'm going to add this x squared. I'm going to add this x squared. So you'll notice that will get me a total of 4 x squareds. I'm going to subtract this one over. That's going to kill that one, so those are gone. And you'll notice I get 4x squared equals 4x squared. So again, you've just proven an identity. When the two sides are equal to each other, we know then this is true. So identities are pretty handy. This identity given here can be used for mental math calculations. Okay, so if I wanted to find the square of 27 without a calculator, okay, 27 squared, what the heck would that be? Well, here's a method using an identity to help you get that. So I'm going to decide if the left side or the right side is more useful. Basically, I want a number squared, so I'm going to start on the left side. And it says, if you can tell me an x and a y that make 27, we can use this identity to figure it out. Now you can pick any numbers you want. Maybe you like 20 and 7. So I'm going to say let x equal 20 and y equal 7. And now I'm just going to plug those numbers into this formula. So 20 plus 7 squared is equal to 20 squared plus 2 times 20 times 7 plus 7 squared. And again, this is just a mental math way to figure out 27 squared without a calculator. So 20 plus 7 is 27 squared, is equal to 20 squared, that's simple. 2 squared is 4, and then you add 2 zeros, so that's 400, plus 2 times 20 is 40, times 7 is 280, plus 7 squared is 49. Now I just add those together. So 400 plus 280 plus 49 gets me 729. And guess what 27 squared is? 729. And you can verify that on your calculator if you need to, if that's not one you've memorized. But again, these identities are just useful in helping you do some mental math. So let's use the identity x minus y times x plus y equals x squared minus y squared to do some more mental math. Basically, if I want to find the product of 37 and 43, I can use this identity to get it. So again, maybe I don't have a calculator or my cell phone or, whatever. So we can use this identity to multiply these. So let me just jot the identity down again. X minus y times x plus y equals x squared minus y squared. So look how simple this is. Basically, if I say product, am I going to use the left-hand side or the right-hand side? Well, this one's multiplying and this one's subtracting. So if I want a product, I'm probably going to start on the side that says multiplying. And then I just say, okay, if I take a number and subtract something, and I take the same number and add something, I need to get a 37 and a 43. Now, obviously, the one that I'm adding is going to be the bigger one. The one I'm subtracting is going to be the smaller one. So now I just ask myself, and hopefully it's pretty easy and you've got it by now, what number am I subtracting and what number am I adding to get 37 and 43? Well, I just kind of went halfway and said I better start with 40. If I have 40 and I subtract 3, I get 47. And if I have 40 and I add 3, I get 43. Do you see what I mean by halfway? Okay, so now I know what x is and I know what y is. Look how easy that was. X is clearly 40 and y is clearly 3. So I know 37 times 43 is the same as 40 squared minus 3 squared. 40 squared is simple. Just square the 4, that's 16, and add on 2 zeros, minus 9. So I know this product of 37 and 43, if I just subtract those, is 1,591. Okay, and again, just using a simple identity to help me add, subtract, multiply, divide, etc. Well, that does it for us. We're going to get some fun practice tomorrow. So if you have questions, you know where to find us.